Okay guys, welcome back. This will be our last lesson for this week, last video lesson. The topic is solving literal equations. It's also in the 1.3. I'm going to probably stop talking about that because by now you should know those numbers are irrelevant to you. It's more organizational for me. All right, solving literal equations, sometimes called rearranging formulas or isolating a specific variable. You're not really finding a solution like we did yesterday, like you isolate the variable and then a number like 7 or -5, that's your answer. It doesn't really work that way. This is more a matter of honing your skills at manipulating equations. I don't really have any notes to give. We just need to jump into the examples. I am going to warn you that once I do this, once I get into these, sometimes one problem will have more than one right answer, and I'll be editing the answer key to make sure that if your answer doesn't match the answer key, that there's an alternative there for you to check. Also, I've rewritten every problem by hand ahead of time just to speed things up a little bit. Now, for number 2, this is going to seem weird, but I'm actually going to do this problem twice. So we've got this equation, u equals k minus x, and we're supposed to solve for x. That means we want x to be isolated. Our answer should be either x equals and then some expression here, or it could be some expression equals x. It doesn't matter if the x is on the left or the right. The fact is it's supposed to be isolated. So one way to do this on this problem would be to, okay, so I'm going to add x to both sides of the equal sign to cancel out the negative x. I've said it before, I don't really like negatives, so if you add x, it makes it go away. Over here on the right, you have u plus x. Well, what's u plus x? It's not something you can do. They're two different variables. They're not like terms. So all you can write down is u plus x equals k. Okay, as it stands right now, the k is isolated. That's not what we want. We want the x to be isolated. That's what the directions say. So to isolate that x, I'm going to subtract u, and the u's cancel out. I get positive x, that's just x, equals k minus u. They're not like terms, so all you can write down is k minus u. And that's the answer. X equals k minus u. Let me check it. Oh, good grief, that's a lot of scrolling. Okay, I have k minus u. They have negative u plus k. It's exactly the same thing. Both of those are right answers. So that's what I was talking about, where there'll be different ways you can, or different looking answers that are both right. A second way to do this problem, instead of adding the x to the other side, would be to do this. I'm going to subtract k, because that is a positive k. Subtract it on both sides and cancel this out. I get u minus k equals negative x. Oops. U minus k equals negative x. Now the x is not isolated. This is like, this negative sign is like having a negative 1, so I divide it by negative 1. And I divide this side by negative 1. That cancels it out. You know, two negatives make a positive. And so u minus k divided by negative 1, what I need to do is I need to divide both of those by negative 1. U divided by negative 1 is negative u. Negative k divided by negative 1, two negatives make a positive. That's plus k. So I get this answer. And as you can see, or if you remember, that's the other right answer from down below. So both of these are correct. It wouldn't matter which way you did it. They're both fine. But the point is, you want to isolate the variable. You don't need to do it twice. I did it twice just to explain options. I don't expect you to do number 1 twice. Don't worry about it. Number 4, z equals a over m. We're supposed to solve for a. So we want this a to be isolated. Well, that's pretty easy. The a is being divided by m. So if you just multiply by m and do that on both sides, times m divided by m cancels out. You just get a. Over here you get m times z, which is mz. So that should be that. Let me scroll down and check number 4. A equals mz, right there, or zm. Okay, it's more standard in algebra to put variables in alphabetical order. Mz and zm are technically the same. That's called the commutative property if you want to know extra terminology, but accept either of those as the right answer. Number 6. This one's kind of like this one, only in reverse. So we want to solve for a. This is a multiplied by k. So divide by k on both sides. The k's cancel out. Times k divided by k, you get u over k equals a. The a is isolated, so that should be the answer. Notice we're not, like I said before, we're not getting solutions per se. We're not getting like 7 or 9 or -2 as a solution. We're just rearranging and isolating the variable. Oh yeah, let me check number 6. 6, u over k, right there. Okay, hopefully so far so good. This is going okay. Number 8 is going to get a little bit trickier. We have g equals c over xy, and we're supposed to solve for x. When x is in the denominator, or whatever it is you're supposed to solve for is in the denominator, that can get tricky. I'm going to have to do a couple of steps here to make this work. The first thing we're going to do is multiply both sides by xy. They're both being divided. Opposite of divide is times. You can do that. That's going to cancel out the x and cancel out the y. So I get xyg equals c. You follow so far? xyg equals c. We want to solve for x. That means I want the y and the g to be gone. Well, if they're both multiplied by x, then I can cancel them by dividing. And of course, you do the same thing on both sides. So y divided by y, g divided by g, that cancels out. I get x equals c over yg. Or like I said before, typically in algebra you do put variables in alphabetical order, so gy. I would say both of those are equivalently good solutions. Let's scroll down to number 8 and look at that. There it is. So it's all basically a game of focusing in on what you want to isolate, look at what's being done, and do the opposite. Opposite of times is divide, opposite of plus is minus, and just manipulate it. Number 10, we want to isolate x. Now, here's one that we can do a little shortcut, and it's pretty easy. We want the c and the y to both be gone. They're both being added to x, so we can just subtract them both at the same time. Just remember to kind of split your equation in half here. So you have to subtract c, subtract y over on the other side. These cancel out. You get x equals, over here on the left, g minus c minus y. Just write it like that. G minus c minus y. That should be the answer. You could also have g minus y minus c. You could have negative c plus g minus y, or negative y plus g minus c. There's lots of different, I'm not going to leave that all on there. There's different possibilities here. The numbers could be commuted. Let's see if that's the way they have number 10. G minus c minus y. Where am I? G minus c minus y. So same answer. There we go. So that one hopefully wasn't too bad. Number 12, solve for a. Okay, so this one's going to take a couple of steps. If I want to isolate a, I'm going to need to cancel out the m, I'm going to cancel out the b, I'm going to do whatever it takes to do that. Now, if these were numbers, let's change everything to numbers. Let's say I had 5 equals 2a plus 1. So it was like yesterday, a regular equation, not a literal equation. What would be the first step here? Hopefully you said minus 1. That would be the first step. And then times, you divide and do that last. So we did the minus step first, and then the divide step. So we're going to follow the same pattern over here. We are going to do the minus step first. Minus b cancels that out. We get z minus b equals ma. And then since this is m times a, we're going to divide by m. Divide this whole side by m. Now, can you divide z by m and b by m? No, they're not the same variable. You can't simplify them. You could just rewrite your answer. Z minus b all over m equals a. And that's it. Let's scroll down and check 12. Z minus b all over m equals a. There it is. Okay, I'm getting tired of this. But we've got more. I'll stick it out just for you because I care about your education. Okay, solve for x. X is right here. We need to, oh, so now there's numbers and variables, and that can happen. These up here all had just variables, numbers and variables, whatever. We need to isolate this x. I'm going to start by adding 3 to cancel that out. That's one step in isolating the variable. What I do on one side, I have to do on the other side, of course. So I get negative 3x over here equals negative 4v minus w plus 3. There are no like terms to combine. All you can do is rewrite it. Now we divide, because this is negative 3 times x, we need to divide by negative 3. Divide this whole side by negative 3. And I'm pretty much done. Now, there's a couple of different ways to write the answer here. Like it's happened on a couple other problems. Generally, you don't just leave a negative sign in the denominator of a fraction. So one method is to, you tell students, just pull it out front. You pull that negative sign out front, even with the bar, negative 4v minus w plus 3, and that's your answer. If I scroll down and check it, that's not going to be the answer they have. I will accept this as a correct answer. Let me write that up. Let me fix that circle. But there's another method for doing this. If you see a negative in the denominator, they say, okay, you need to multiply by negative 1 over negative 1. What that does is on the bottom, clearly, negative 3 times negative 1 is positive 3. Same result, you don't have a negative on the bottom. On the top, you have to distribute a negative 1 into the whole thing. And you get positive 4v plus w minus 3. So this negative 1 basically changes all of these signs to their opposite, and then you end up with this as an answer. These are both technically the same answer, and they're both correct. They just don't look very much alike. All right, let me scroll down to number 14 and show you that they have this answer. The answer I got the first time, well, and it was out of order too. What did I have? I had like negative 4v minus w plus 3. These are both equivalent answers. So either one of those is good for number, where am I? Number 14. All right, let's look at number 16. Solve for x. X is right here. So how am I going to do this? Well, I'm going to try to kill two birds with one stone. I'm going to add 6 and subtract 3y in order to isolate that x. That means I need to add 6 and minus, oops, isn't that weird? I can say one thing and write something completely different. Add 6 minus 3y. So I'm doing the same operations on both sides. This side, it makes those things cancel. I get 6x. Over here on the left side, you really can't do anything other than copy it down. U minus 3y plus 6. Now, is x isolated? No, it's times 6, so you divide by 6. Divide everything here by 6. And x is now isolated, u minus 3y plus 6 over 6. And that is, or should be, the answer. Let's see if it's one of those where there's multiple right answers. Probably not, because there's no negative. Yeah, that's it right there. Okay. What do we have left? Number 18. All right, this one is going to be a little bit tricky. We need to solve for x, but look, there's an x here and an x here. So I need to try to do a good job in explaining how this is done. First, if you have the same variable in two different spots, you need to get them on the same side of the equal sign. So I'm going to add 4kx, add 4kx. This cancels out, I get negative 4. Now, can you add these together? Negative 3 plus 4 is 1. No, this is yx and that's kx. They are technically unlike terms, so you cannot combine them. All you can really do is write them down. Oops. Negative 3yx, excuse me, plus 4kx. Okay, so now we're supposed to isolate x, and it's on both sides of the or it's on the same side of the equal sign now. The next step is called common factoring. We're going to pull out a common factor. It's kind of like the distributive property in reverse. We're going to undistribute that x, and we end up with this. Normally when you distribute, you start here and you multiply this into the parentheses, and you end up with that. When you do the opposite of that, it's called factoring or common factoring. The thing we're trying to isolate, it's common. You can see how I have it highlighted there. Right here, and you pull it out. Now, to isolate that, because this is times, we can simply divide both sides by that grouping in parentheses here. So divide this by negative 3y plus 4k. Obviously, when you multiply and divide by the same thing, those things cancel out. We get x over here. On this side, we get negative 4 over negative 3y plus 4k. This is correct. I have a feeling maybe this will be one of those problems where there's an alternate correct answer. So let me scroll down and check. Yeah, that's, oh, those goofy, silly people. Okay, so this is a correct answer. Let me show you how they get the alternate answer. So negative 4 over negative 3y plus 4k. They did that trick I did before where you multiply top and bottom by a negative 1. So on top that gives you positive 4, and on the bottom, when you distribute this, gives you positive 3y minus 4k. If you get this answer and stop there, I would give you credit for it, but this is the answer in the answer key. Okay, so number 17 is going to be a lot like number 18. You've got x on both sides of the equation. So you're first going to want to get them together on the same side, so transport that term over to here. Then factor out the x like I did in this step. And then divide to solve and finish off number 17. If you struggle with number 17 because it's a little bit more complicated than the rest, that's understandable. Do your best. Let me know if you have questions or need help, and I can probably do something like number 17 during our live session. Okay, I'm going to stop there. Do your best on the odds. Questions or comments?